So we jump into it. Sarah, you can see the screen? What are you seeing on the screen right now?
So I see a graph on the right hand
Alright, no
side
see.
and
Now this is actually the question that we did in the last class. At the end of the last class, we were given a question where we were given these two equations here. Y is equal to x plus 1, which you could see is the blue line, and y is equal to minus x plus 5, which you can see is the green line. You don't have to write this over. This is actually, we actually did this already, right? Um, you could see here that the blue line and the green line, they do intersect at a point, and we had to draw, the question wanted us to draw these lines and find out where they intersect. And we could see that the point that they intersect is the point 2, 3. What that means is that that point 2, 3 is lying on both of those lines. So you have an x value of 2 and a y value of 3. And that x and y value will satisfy both the lines, right? JQ, you'll be right back already, boy, for real? That x and y value will satisfy both the lines, and we could see that here. We could see that if we take 2 being the x value and we put it in the first equation for x, 2 plus 1, we will get 3 for y. Yeah? So 2, 3 works in the first equation, and if we check the second equation, we take the 2 and we put it here for x. So we have minus 2 plus 5. Well, guess what? Minus 2 plus 5 is 3. So 2, 3 works for both equations. What we did was we solved the two equations simultaneously. Meaning, when to solve simultaneously means you're finding the one point that is common for both lines. And so we solved this simultaneously using the graphical method. And the graphical method is essentially coordinate geometry, where you take you find your 2 points and you plot your lines, and then you actually read the intersection of the graph. So, as I say, you don't really need to write this down, but we are getting to the writing here. We're talking about simultaneous equations. That is, you're given two equations and you're finding that one point where the two equations will intersect, right? So finding the values of x and y that will satisfy both equations. That is what simultaneous equations, that's what that is, right? You can see we have 4 methods here. We already did the first method, which is the graphical method. Right? That's what we were just talking about. So you're given 2 equations and they ask you to solve it simultaneously using the graphical method. That is what you would do. Today, we are going to talk about these 2 methods, the elimination and the substitution methods. We will not be doing the matrices method right now. That will come closer to the end of the curriculum when we are actually doing matrices. So when we're doing matrices coming close to the end, which should be before Easter. So we're going to do the elimination, the substitution, and then the matrices method will come after. So let's get it going. So simultaneous equations, finding the value of x and y that will satisfy both equations. We have the methods here, the graphical method, elimination method, substitution method, and the matrices method, which we're not doing today. Right, let me talk about the elimination method. With the elimination method, we can add or subtract both equations to eliminate one of the variables, X or Y. All right, sorry for the handwriting. I will try to do better. So we could add or subtract. So you can see I have the same two equations here, you know. So you know what the answer gonna be. You know the answer gonna be 2, 3, right? The same two equations here. We will call this one equation 1. We will call this one equation 2, right? What I am looking at is you look for the same, and this is a big word here, coefficient. What is the coefficient? The coefficient is the number in front of the variable. So if you have 2y, the coefficient is 2, the number in front of the y. Yeah? If you have minus 3x, for example, the coefficient will be minus 3. Right? So what we're looking for is we're looking for those variables that have the same coefficient. So let me check it out, right? Let me see. Zafir, what is the coefficient of this x over here? Feel free to be wrong.
It's 1, sir?
Yes, absolutely. It is 1. Where's the coefficient of this x over here? And
Negative 1?
Yes, correct. And I'm just rewriting it, negative x plus 5. So we have the coefficient here being 1, negative 1. They're not the same, right? What about the coefficient of y? Where's the coefficient of y here? Ade, where's the coefficient of y here? This is going to be a long class.
2, remember.
Yeah, the coefficient is just the number in front. You seeing any number in front of y there?
Nah.
All right, well, that means that it's going to be 1, and?
Yeah.
Because remember, we don't need to write the 1. The 1 is understood. It can't be 0 because 0 times y is 0 and there would be no y, right? So it have to be 1. It had to be 1. So you see the coefficient of this y is 1. Where's the coefficient of this y here, Adi?
1, 2.
Right. So that means the y's, both of the y's have the same coefficient, right?
Yes, sir.
So now I could minus them, right? You could add or subtract, right? So you could do equation 1 minus equation 2, right? So let's see what that will give us. Y minus y, well, that will give us 0. So we eliminated y. So you see that? You see why it is that we wanted the same coefficient. Because when we have the same coefficient, we could actually minus them and eliminate something. Yeah? But you had to be real careful. And I got come in my working column here. Right? Y minus y is 0. You had to be real careful because now I have x, which is here. Right? I have this minus sign, and then I have a minus x. You see that? Plenty people would have go x minus x and mess that up. No, you had to be real careful with this, with them signs. So you have x, you have the big minus sign, then you have minus x. And we all know x minus minus x. Well, that is x plus x, which is 2x. So now the x's will give me 2x. And now on this side, I'll have 1 plus 1 minus plus 5, right? So that's plus 1 minus plus 5, which is just 1 minus 5. When the signs are different, you find the difference and you keep the sign of the larger number. So what I did here, I just subtracted both equations. I was able to eliminate the y. And so now I ended up with an equation with only one unknown. 2x minus 4 is equal to 0. You throw across the minus 4. So therefore 2x is 0 plus 4, right? Which will be 4. 0 plus 4 is 4. And x will be 4 divided by 2. X is equal to 2. X is equal to 2 in any one of these equations. You could do it in equation 1 or you could do it in equation 2. You'll get the same answer for both of them. So sub x is equal to 2 in, let me go equation 1 looking easier. So that means that equation 1 is y is equal to x, which is 2, plus 1. Y is equal to 3. Therefore, x is equal to 2 and y is equal to 3. We knew that was going to be the answer. This is the elimination method. Ade, do you understand this elimination method?
Before I didn't understand it, but I understand it now, sir.
All right. All right. Y is equal to x plus 1 and y is equal to minus x plus 5. Now, I could still recognize that the coefficient of x is 1 and the coefficient of this x is minus 1. Technically, you know, both of them is both of them is 1. It's just one is negative. So instead of eliminating y, I could eliminate x instead. Just in this case, it's possible for me to recognize that I could eliminate the x by adding the equations. If I add the equations, what will happen? Right? Y plus y is 2y. But look at what will happen here, and I'm going to put it here in the working column. I have x in the first one, and then I have plus, and then in the second one I have minus x, and we know that the plus don't matter there. So that is just x minus x is 0. So the x's are gone. We have 0. So we eliminated the x's. So it just so happens that if I minus the equation, I could eliminate the y's. But if I add the equation, I can eliminate the x's, because one of the x's is 1 and the other one is minus 1. So 1 minus 1 is 0. And then you have what? 1 plus 5 is 6. So what do we end up with? 2y is equal to 6. Therefore, y will be 6 divided by 2, which is 3. And then you just do the usual. Sub y is equal to 3 in any one of the equations, right? So let me go in equation 1. Equation 1. Equation 1 is y is equal to x plus 1. So I will put 3. Y is 3, right? Is equal to x plus 1. You throw the 1 across, you'll get x is equal to 3 minus 1, which is 2. Therefore, x is 2, y is 3. So with the elimination method, you just kind of had a look at the x and the y's and see which one could be eliminated. The hardest part of the elimination method is deciding whether you should subtract the equations or whether you should add the equation. So we saw two examples using the same equations here where we could have eliminated a y by minusing, but we could have eliminated x by adding the equations. So that is what the process of elimination is about. Eliminating one of them so that we only have one of them and we could solve it, right? Solve simultaneously, right? This is another example here where you could see that I have, just now, right, yeah. You could see that I have a minus 1 here and I have a 1 here. So you know that I could eliminate y if I added the equations. So by adding the equations, I could say, well, you know what? Let me see. Yeah. By adding the equations, I could say that 2x plus 3x, well, that'll give me 5x, right? But then you have minus y plus y. If you're not sure, go in your working column. Write it out. Minus y, you have the plus sign, and then you have an next y. Minus y plus y is 0. So the y is gone there. And then I'll have 5 plus 10, which is 15. Right? So now I end up with 5x is equal to 15. You know, x will be 15 on 5, which is 3. Now, once I have x, I could sub x equal to 3 in any one of the equations. Equation 2 looking like it could be easier because it have a positive y there. All right, so let me go with equation 2, right? 3x plus y is equal to 10. I substitute in x is equal to 3. So 3x, which is 3, plus y is equal to 10. 3 3s are 9 plus y is equal to 10. You throw the 9 across, you'll get y is equal to 10 minus 9. Y is equal to 1. Therefore, when x is 3, y is 1. That means that if you draw these two on a graph, they will intersect at the point 3, 1. What should I do here? Should I add these equations or should I subtract them? Real quick, for anybody who want to leave early. We could get
Add them.
You add them. All right. Why? Why are you adding them? To get rid of what?
So if you add them, you get rid of y.
If you add them, you'll get rid of y. So she recognized that. So you could add them. So then you'll get x plus 2x. That is 3x. And she saw that minus y plus, and I have a positive y, that will eliminate and give me 0. So minus y plus that positive y will be 0. And then I have 11 plus 19. Do I really need to add that? All right, 19 and 10 is 29, and 11 is 30. All right, so 30. Oh, well, look, this worked out good, right? So what do we have? We have 3x is equal to 30. X will be 30 on 3, which is 10. And so now we just sub x is equal to 10. And let me go with equation 2 because it have a positive y. I don't want to have to deal with a negative y. I'm just lazy, you know. So that is 2x, which is 10, plus y is equal to 19. So that means that 20 plus y is equal to 19. I throw across the 20. Y is equal to 19 minus 20. Y is equal to negative 1. Therefore, when x is 10, y is negative 1. Right. So we can change the coefficient, not just of x, but of y. So let me put of x and y. So we could change the coefficient of x and y, because if you look at this equation here, you could see that in this equation, we don't have any of the coefficients that are the same. None of the coefficients are the same. The x is 2 and this x is 3. So if I add or subtract, I can't eliminate x. And look at the y. The y here is minus 1. And this y here, the coefficient is 2. So if I add or subtract minus 1 from 2, I'll never get 0. So you cannot eliminate y.
Just like that.
Ade, which one would you like to eliminate? X or Y? Say X. Say X. X. All right, yeah. So Ade say that he wants to eliminate X. Now, you could use this method for X or Y, right? But what we're going to do, right? I could change the coefficient. If I decided that I wanted to eliminate the X's, check what I'm going to do. I'm going to take this equation, 1. You see how this equation, X's have a 2. And this equation, X have a 3. So I'm going to take equation 1 and multiply it by 3. Just now, I'm going to write that a little better. I'm going to take equation 1 and multiply it by this 3. But then I'm going to take equation 2 and multiply it by this 2 over here. So I'm looking at the coefficients and I'm multiplying this equation by 3 and I'm multiplying this equation by 2. And watch what will happen. If you multiply this whole equation, you have to multiply both sides by 3. Right? So you multiply 3 times 2x. That'll give you 6x. Right? Imagine you have a 3 outside here. 3 times 2x is 6x. 3 times minus y is minus 3y. And then you have a 3 here. 3 times 5 equals 15. So what I just did was I just found a bigger multiple of the equation. It's still the same equation. It's kind of like, you have 2 over 4. Or you have, 5 over 10. Or you could have 10 over 20. Or you could have 20 over 40. Or even 25 over 50. Or even 100 over 200. No matter what you have, is still just a half. That's all that it is. No matter how fancy you want to put it, it's still just the same thing, a half. Same thing with these equations here. This equation that I found is the same thing as the first one, right? So you notice I multiply the first one by 3. Let me multiply this one by 2. So I'll multiply this by 2. So 2 3s are 6x. Well, look at that. You see why we did what we did now, right? And then 2 2s are plus 4y, right? And that is equal to 2 times 10 is 20. So I'll multiply equation 1 by the 3 in front of this x. And I'll multiply the second equation by the 2 in front of this x. By doing that, they both become 6x. And so now I can eliminate them. Let me call this equation 1 and let me call this equation 2. Even though you have 4 equations. So you could call it 3 and 4, Let me call it 3 and 4. Let me call it 3 and 4. We'll call this equation 3 and you'll call this equation 4. But equation 3 is the same as equation 1, by the way, right? So now I could minus 6x minus 6x. That is 0. So I finally was able to eliminate the x. I have here, careful, and I'll come in my working column here. I have minus 3y minus, and then I have plus 4y. Right? When the signs are the same, you add them, 7y, and you keep the sign. So you had to be real careful here. Yeah, and then on this side, I'll have 15 minus 20, which is minus 5. All right, wow, this question looking like it could be a little bit of stress, right? So now I have negative 7y is equal to negative 5. Y will be negative 5 on negative 7. The negatives cancel. So y is just equal to 5 on 7. Yes, you can get fractions. So you can see here that when the coefficients are not the same, you could use multiplication to make them the same. And so now, let me sub y is equal to 5 on 7 in any one of the equations. Let me see which equation might work out best. Oh gosh, all of them look like they're going to be stressful, boy, with these fractions. 5 on 7, nothing I go cancel, nothing I go cancel, nothing I go... You know what, let me go with equation 1, yes? In equation 1. So what do we have in equation 1? 2x minus y, which is 5 on 7. That is so painful, is equal to 5, right? You throw across the 5 on 7, oh God. 2x is going to be 5 plus 5 on 7, which is 5 and 5 on 7. Yeah. Which is 5 and 5 on 7. Am I correct there? Yeah. 7 5s are 35. All right, so 2x is going to be 40. 7 5s are 35. And 5 is 40. So 40 on 7. All right. Throw across the 2. And let me know if I'm making any mistakes. I do make mistakes as well. X is equal to 40 over 7 divided by 2 as I multiply by 2 here. Remember, 2 over 1 is divided by 2 over 1. So, when you are dividing by a fraction, let me just move this out of the way. When you are dividing by a fraction, you flip and multiply. Sorry to give all you one that ended up in fractions. My humble apologies. X is equal to 40 over 7 multiplied by 1 over 2. So 2 into 2, 1. 2 into 40 is 20, right? Yeah, 40 divided by 2. So x is equal to 20 over 7, which is 7 2s are 14, 15, 16, 17, 18, 19, 20, and 6 over 7. So therefore, x is 2 and 6 over 7. Y is 5 over 7. Sorry for the fractions, guys. It has turned out so sometimes too. So you had to know your rules of fractions and things, as you could see. I hope I didn't lose anybody with this one though. JQ, I lost you with this one. So the whole point of this question wasn't all of the fractions. The whole point of this question was that when you can't eliminate nothing because the coefficients are not the same, you could make the coefficients the same by multiplying. If I wanted to, I could have chosen to make the coefficients of y the same as well. I would have multiplied this equation by -1, and I would have multiplied this equation by number 16. When you finish, leave your answer in the chat. You have to use the elimination method. In fact, let me write it down so that people wouldn't do the wrong one, right? So what do we have? 2x plus y is equal to 20, and then 6x minus 5y is equal to 12. Notice none of the coefficients are the same. So you have to choose who do you want to eliminate, x or y, and then you multiply by the numbers according. In this question, I could give you a hint. You don't even have to multiply both of the equations. You could just multiply the first equation by 5, and you're going to end up getting a 5y, and then you could subtract it normal. So you don't even have to multiply both of the equations. You can multiply just one equation in order to get them to match. So just multiply equation 1 by 5 so that you'll end up with 5y, and then eliminate the y. All right. So I get at least one answer from the fellas, right? So all you had to do is multiply equation 1 by 5. If I wanted to eliminate x, could I multiply this equation by 6 to get 12x, and then multiply this equation by 2 to get 12x. But eliminating the y's will be a lot easier, because all I had to do is multiply equation 1 by 5, and so what will I get? 5 2s are 10x plus 5y is equal to 5 2s are 10, 100. So I have equation 3 here, and then I have my normal equation 1 here, 6x minus 5y is equal to 12. Here comes the question, should I add them or should I subtract them in order to get rid of y? This is where you have to be very careful. A lot of people would have subtracted, but remember 5y minus 5y will be 5y plus 5y. So no, you have to add them, right? So when you add them now, 10x plus 6x is 16x. You get, and I'll go here, 5y plus minus 5y. Well, that will eliminate and give me 0. All right, so that is 0. And then on this side, I have 112. So I have 16x is equal to 112. X is 112 divided by 16. Is not another fraction. X is 7. X is equal to 7. I have 3 equations. I have equation 1, I have equation 2, and I have equation 3. I could use any one. Which is the easiest one, boy? I would say equation 1. So let me go with equation 1. In equation 1, x is 7. So 2x, which is 7, plus y is equal to 20. You throw across that, y is equal to 20 minus 7 2's will give you 14. So y is equal to 6. Therefore, x is 7, y is 6. We're moving on to the substitution method. And the substitution method is slightly more difficult, but substitution, yeah, you do have to know it, because when we reach quadratics, it'll have simultaneous equations involving quadratics, and you will not be able to use the elimination method there. You'll have to use the substitution method. So it is an important method to know, right? So what I could realize is this.
Yes, I
I just always pick on it.
Yeah, right.
Yeah, I don't know where it is. I don't know where it is. But here we are, right? And you see that y is equal to x plus 1?
Yes, sir.
But isn't this the same y that is also equal to this?
Yes, sir.
Right? So, you know, you have y is equal to x plus 1. And you have, you know, so this here, Adi, this here is y, and?
Yes, sir.
Right. So from equation 1, y is equal to x plus 1. I'm going to sub that y is equal to x plus 1 in equation 2. So what is equation 2? Y is equal to minus x plus 5. That is what equation 2 is. Notice y is equal to x plus 1. So wherever I see y, I'm going to substitute it and put x plus 1. So therefore, x plus 1, because that is y, is equal to minus x plus 5. Now I only have one thing to solve, one unknown. I could throw this x across here. So I will have x, and this will become plus x is equal to, I'll throw this 1 across here. So it'll become 5 minus 1. Right? Therefore, 2x, x plus x is 2x, is equal to 5 minus 1 is 4. And now you can see x is 4 divided by 2. X is equal to 2. If you want, you could stay back after the class and talk to me if you want. Or you could talk to me on the WhatsApp, no problem. Anything you want to do. No problem, because I'll have to show you what all the stuff you missed and stuff anyway, right? You can see here from now, it's just good old sub x is equal to 2 in equation. You could do any one of them. Let me do equation 1. So y is equal to x plus 1. Y is equal to 3. Therefore, x is 2. Y is 3. This is the substitution method. So look, I have another example here. And I think this was the example where we get a set of fractions, you know. So please forgive me if we end up with a set of fractions. I think this might be the example, you know. So yeah, you know, I could eliminate it, but check this out. Oh, nah, boy. Yeah, boy. This is the one where I end up with a set of fractions. Yeah. Now, you know what? Fire for that. I don't want to deal with no fractions now because fractions will distract us. So we go deal with the fractions when we do in the questions class. But fractions will distract us from the point. So let me choose one of these questions. Here, I'll choose this. All right, I'll choose this one, number 13, right? Somebody remember that for me, minus 3x. You know what? I'll just write it down here. Minus 3x plus 3y is equal to 4. And then you have minus x plus y is equal to 3. So we're using the substitution method now, right? This is equation 1. And this is equation 2. So with equation 2, I could see, check this out. From equation 2, I could see that minus x plus y is equal to 3. You throw the x across, and I'll get y is equal to 3 plus x. So this is what y is. Y is 3 plus x. So I could substitute y is 3 plus x. This is equation 2. So I'll substitute it in equation 1. What is equation 1? Equation 1 is negative 3x plus 3y is equal to 4. Remember, I'm substituting y is equal to 3 plus x. So wherever I see y, I'm going to put 3 plus x. So negative 3x plus 3y, which is 3 plus x, is equal to 4. So negative 3x plus distributive law, 3 times 3, 3 3s are 9, and 3 times x plus 3x. I see Anaya having some real connection problems, but negative 3x plus 3x, right? And I mean, honestly, I'm sorry I chose this this example here. Sorry I chose this example because we ended up getting something that, but we had to learn about this anyway. So check what's going on here. Negative 3x, and I have, wait, did I write it down wrong? No, I didn't write it down wrong. Okay. Negative 3x plus 3x. Well, that is cancel. That'll give me 0. So what I ended up getting here, I ended up getting 9 is equal to 4. Well, let me take a look at the two equations. Remember, these equations are lines, right? They are both lines. So let me take a look at equation 2. With equation 2, we have negative x plus y is equal to 3. So therefore, y is equal to 3 plus x, or x plus 3. All right. So you could see in this line, this is of the form y is equal to mx plus c, right? Y is equal to mx plus c, where m is 1. The coefficient here is 1. Notice that. Notice equation 1. Equation 1 is negative 3x plus 3y is equal to 4. You throw this across, so I'll get 3y is equal to 3x plus 4. This is not in the form y is equal to mx plus c. I had to throw across this 3 to get y is equal to 3x divided by 3 plus 4 divided by 3. Everything divided by 3. So y is equal to x plus 4 on 3. I don't really care about what 4 on 3 is, but look, the number in front of x is also 1. So the equation, when we put these two lines in the form of y is equal to mx plus c, y is equal to mx plus c. For both of these lines, we get m being the same thing. What do we know about two lines where m is the same thing, where m is equal? What do we know about that? Let me see. We do coordinate geometry last week. Yes, Sarah. What are you saying?
The parallels, so when you work, like when you're trying to solve it simultaneously, you didn't get an answer because they would never intersect.
Exactly. Yeah. So when you have two lines that are, and I just did all of this working to show earlier. You guys did not need to do this working. Yeah. I just put the equations in the form y is equal to mx plus c, just to show you that m is the same for both equations. And I thought it would be that way because if m is both the same, that means the lines are parallel. So parallel lines do not intersect. One line coming so, the next line coming so. They don't intersect. They would have no point of intersection. So when you try to solve them simultaneously, you're going to end up with some nonsense like 9 is equal to 4, something that could not possibly be true. Right? So when you solve in a simultaneous equation, and as I say, you don't need to do this in the box here. You do not need to do this. I just did this to show you that they are parallel, that they have the same gradient. But when you solve in a simultaneous equations and you reach this point where you're like, well, then the answer here is no solution. The lines do not intersect, and therefore they do not share that one point of intersection. So I'm afraid that I wanted to demonstrate substitution, and I did demonstrate the substitution method over here, but I chose the wrong example. This example, it ended up not intersecting. However, it is an important example for you to see because you do end up with questions like this. You do end up with questions where the lines do not intersect. And so you'll have no solution. So it wasn't the example I intended, but it still worked out to be a good lesson. Right? So now we will do an example that is a little bit more in line with the substitution method. So I'll choose a different example this time. But this is an important example. We had to learn this anyway. So I'm kind of glad that I chose this example. I'm glad that we did this example because you would have bounced up this question and be like, what? And then you would have tried something else and you would have still get nonsense. And you would have tried something else and you might have tried the process of elimination and you would have still get nonsense. And you'd have be like, what the hell going on with this question? But no, the lines are parallel, so they'll never meet. So that you cannot solve them simultaneously. So when you reach a point like this, you literally put this as your answer. No solution. So an actual substitution method this time. That last one was the substitution method, but it just turned out to be parallel lines, right? So this is equation 1. This is equation 2. So the whole thing about the substitution method is you want to, look for something that is easy to make the subject of the formula. So I could see here that this x, it's easy for me to make that the subject of the formula. So from equation 1, I could see that x is equal to, I'll take this 5y and I'll throw it across. I throw in across the 5y. So I'll have 1 minus 5y, right? So I made x the subject of the formula, right? X is equal to 1 minus 5y. Now I could sub that in equation 2. Sub meaning substitute. All right. So what is equation 2? 6x plus 4y is minus 10. You notice x from here, x is 1 minus 5y. So wherever I see x, I'm going to put 1 minus 5y. So 6x, which is 1 minus 5y, plus 4y is equal to negative 10. So now I just expand this out. 6 times 1 is 6. And 6 5s are 30, right? 30. 7 5s are 35. 6 5s are 30. So that'll be minus 30y plus 4y is equal to minus 10. Well, minus 30 plus 4 is what? That is minus 26. Minus 26y is equal to, I'll take this 6 and I'm throwing it across. So I'll have minus 10 minus 6. Right? So minus 26y. Let me see if I get that correct. Right? So minus 26y is equal to minus 16. Oh God, it's looking like we ended up with fractions again. So y is going to be minus 16 divided by minus 26, which is, where does it get when you reduce 16 over 26? Reduce that, somebody.
So 8 over 13.
8 over 13. Oh God, look at that ugly number. God. I hate when I'm doing simultaneous equations and I end up with fractions, bro. That is be so annoying. You guys probably will not in your exam. In your exam, they will probably keep you with simple numbers. So, doing these harder questions is good for your practice. But in exam, they'll leave you with simple numbers. So just understand the process. Right? So look at the process. That was the substitution method there. And I just really need to go and substitute y is equal to this ugly looking thing in any one of these equations. Any one. Right? But the substitution method is essentially, you find one of them to make the subject of the formula. I make x the subject of the formula here. If we looked in this example we did up here, you could see that y was already the subject of the formula. So we didn't have any rearranging to do. In this case, we had some rearranging to do, because nothing was, the subject of the formula. So I make x the subject of the formula. That means x is equal to this. And I could now take this and put it in the equation. Let me work out this now. Y is equal to 8 over 13 in equation. Well, that 13 is a stupid number because that I'm going to cancel with nothing, right? So therefore x is equal, no, not equal to. X plus 5y is equal to 1. That means that x plus 5 brackets 8 over, 8, you know, that is equal to what? 5 eighths are 40. So x plus, you know, you're multiplying your brackets, so you multiply your numerators and your denominators, right? Multiplying fractions. So 5 eighths are 40 over 13, and that is equal to 1. X is equal to 1 minus 40 over 13, right? Let me just say we could substitute 1 as 13 over 13 minus 40 over 13. So therefore 13 minus 40, this gives me negative 27 on 13. Yeah, that's 2 on something. Right? 2 on 1 over 13. So x is negative 2 on 1 over 13. Ugly, ugly answers, boy. I hate when you're doing it and you get ugly answers like that. It just makes you feel like you do something wrong, you know? Now, Ade, how do you feel about the substitution method?
Can we analyze the elimination, but okay.
You understand it?
Yeah, a little bit.
All right. So I'll probably do just 1 or 2 more questions that do involve fractions. You see, when we have questions that have these fractions in it, you know, you just get distracted by how hard the fractions are, because, you know, everybody afraid fractions. So they just get distracted by the fractions and they don't focus on the actual method of substitution. So I'll do one of the earlier examples here. Anybody still writing here? I'll give you guys a little 30 seconds. We'll just do 1 or 2 more questions and that is it. You know, it's just a couple of questions in the substitution method and that'll be it for simultaneous equations. Of course, you'll have some questions to do, and in the next class, we will spend the whole class just doing simultaneous equations questions, right? But that's pretty much it. As I said, the matrices method is one that we'll have to do when we do in matrices. So we will see simultaneous equations again. So let me go up here now and look for when we did the elimination method. And I know we are getting no fractions for the answers for this one, right? We might have to deal with fractions, but at least no fractions in the answer, right? So it have nothing to make the subject of the formula here. Remember, you wanna substitute x is something or y is something. So I see the easiest thing to do. This is equation 1, this is equation 2. The easiest thing to do to me is to make this y the subject of the formula, right? So in equation 2, all right, so from equation 2, I could see that y is equal to, I'll have the 10, and then when I throw the 3x across, it'll become minus 3x. So it was easy for me to make y the subject of the formula here. Y is 10 minus 3x. That is what y is. So I will now sub, and this we got that from equation 2, so I'll have to sub it in equation 1. Sub in equation 1. What is equation 1? 2x minus y is equal to 5. This is what y is. You notice I have the y in brackets, right? So that means that 2x minus, and I'll use my brackets, y inside of here is y. This is y, and that is equal to 5. Wait. 2x minus y is equal to 5, yes. 2x minus y is equal to 5. I thought I mixed up the equations there for a minute. right? So this is a minus 1 outside of these brackets here. So when you expand the brackets, 2x minus 1 times 10 will give you minus 10. And minus 1 times minus 3x will give you plus 3x, right? It's just a matter of doing the algebra. So 2x plus 3x is 5x minus 10 is 5. And look, I'll get 5x. You throw across the 10 is equal to 5 plus 10. So 5x is 15. And then you get x is 3. And that was the substitution method right there, right? The rest of the question is the same as the elimination method, where you take, substitute x is equal to 3 in any one of the equations. Let's use equation 2. So 3x, which is 3, plus y is equal to 10. So you could see y going to be 10 minus 9, because this 3 times 3 is 9. Throw it across. It'll become minus 9. Y is equal to 1. So this is a much better example of the... we shouldn't get no fractions there, even though the numbers are looking scary, right? So we have equation 1 and we have equation 2. And I could see that, you know what? Equation 1, this x looking like the easiest thing to make the subject of the formula. Because from equation 1, I could see that x is equal to, throw across that y, I will get 11 plus y, or y plus 11, right? And now you just substitute that in equation 2, which is the other equation. So x is equal to 11 plus y. So what is equation 2? 2x plus y is equal to 19. Wherever I see x, I'm going to put this. So therefore that is 2x, which is 11 plus y, plus an xy is 19. So that is 2 times 11 is 22, plus 2 times y is 2y. Then I have plus y is equal to 19. You gotta be real careful, right? So 2y plus y is 3y is equal to 19. And I'll take the 22 and throw it across. It'll become minus 22. So 19 minus 22 is negative 3. So 3y is negative 3. Y will be negative 3 divided by 3, which is negative 1. And that is it for the substitution method there, That is it. We finished with the substitution method there. It's just to sub y is negative 1 in any one of the equations. Let me go with equation 1. All right, let me go with equation 2. All right, where's equation 2? 2x plus y is equal to 19. You see, y is negative 1. So that means 2x plus negative 1 is 19. So that means 2x minus 1 is 19. Throw that across. 2x is 19 plus 1. 2x is 20. So therefore we could see that x will be 20 divided by 2, which is 10. And look, we get the same answer. X is 10 and y is negative 1. So without the fractions, the substitution method is actually quite easy. You just have to kind of decide which one. And you could see I could have made this y the subject of the formula. Y is equal to 19 minus 2x and substitute that in equation 1. You're looking for the easiest way out. And I saw that, well, making this x the subject of the formula might have been the easier way out. If I had made this y the subject of the formula and I had gotten 19 minus 2x, I would have had to substitute it in this over here, which have this negative sign in front of it. And that could complicate things a little bit, right? So you have to see the choices that you're making. The choices that you're making will help you in terms of making this job easier or not, right? Anybody have any questions on simultaneous equations, though? Sharice, you understand. Have a good evening, and I'll see you on Saturday.